Let's say if we have a matrix A and it's equal to 2, 3, 4, 5, 6, 7, 8, 9, and 10 here. Notice that this is a 3 by 3 matrix, or we can call it a square matrix, because the rows and the columns are equal. The numbers of rows are equal to the numbers of columns. So in this case, it is a square matrix. So adding two matrices, and let's assume we have another matrix that is 1, 0, 2, 0, 1, 0, 2, 2, 2 here. So the sum of these two matrices, we can say matrix A plus matrix B is equal to, now we can add the element of this matrix to the element of this matrix. Like the first element of this matrix is 2 and the first element of this matrix is 1. So we are going to add these two elements. So it is going to give us 3. And the second element of this matrix in the first row is 3, while the second element in this second matrix is 0. All right. So we're going to add 3 plus 0. That is going to give us 3. The same apply here. This and this is going to give us 6. And 5 plus 0 is going to give us 5. 6 plus 1 is going to give us 7. 7 plus 0 is 7. 8 plus 2, that is 10. 9 plus 2, that is 11. And 10 plus 2, that is 12. So this is the matrix that we got after adding those two matrices. So as for matrix subtraction, it is going to be the same. So notice that you can only add two matrices if the dimensions are the same. Let's say, for instance, if the dimensions of matrix A is a 2 by 2 matrix, and the dimension of matrix B is 2 by 3 matrix. Notice that these two matrices cannot be added. They cannot be added. And likewise, if you also have the dimension of A as a 2 by 2 matrix, and the dimension of B2 is also a 3 by 3 or 2 by 3 matrix, and we cannot also subtract. We cannot perform a subtraction with those two matrices. So we cannot add and can subtract. You can also subtract. All right. So now, in order to determine the matrix that is going to be formed after you have added two matrices, or after you have multiplied two matrices, is this. Let's say, for instance, if you have matrix A here, and it's equal to 2, 3, 2, 4, and you have matrix B, which is also equal to 1, 2, 3, 4. By looking at this matrix, we can easily determine that this matrix is going to be a 2 by 2 matrix that is going to be formed, right? So if you have a 2 by 2 matrix and a 2 by 2 matrix, first of all, in order to determine the matrix that is going to be formed, is to look at those two numbers at last, the rows of this matrix and the columns of this matrix is going to be the new matrix that is going to be formed. So in this case, we're going to have a 2 by 2 matrix. And in order to perform matrix multiplication, the row of the first matrix should be equivalent to the it should be the columns of this first matrix should be equivalent to the row of this second matrix. So the column of this first matrix is a 2, and this here is also a 2. So this can be multiplied. Let's say matrix A is equal to this, and B is equal to this one, right? So these two matrices can be multiplied. But if you have a matrix as A is 2 by 3 and B is 3 by let's say 2 by 3 matrix, by looking at these two numbers, it is not the same. So we can see that these two matrices cannot be multiplied. A and B cannot be multiplied. For example, we can do that here. Let's say, for instance, if matrix A here is a 2 by 2 matrix, A is a 2 by 3 matrix, that is 2 rows, so 1, 2, and 2 rows, 1, 2, and 3 columns. So we need to add one more column here, so 1, 1. And we also have another matrix, which is a 2 by 3 matrix. That matrix is this one, 2 by 3. That is 2 by 3 matrix. So we have 2 rows. Let's say 1, 2, 1, 2, 3. So these two matrices cannot be multiplied. Why? Let's say, for instance, if you decide to multiply this matrix, the first thing you have to do is to first multiply this number by this number by this number, and now the last number here, it has no rows to be multiplied by. So in that case, it is not going to be possible, right? So it is not possible in this way. So that is the reason why whenever you are given two matrices to multiply, the first thing you have to do is to actually observe the dimension to see whether there's a similarity between those two dimensions. So thanks for watching this video. Goodbye.